Hello, welcome to you all. I am Senthil Kumar, a computer science engineer, and I am working on multidiscipline engineering. I'll just introduce myself. I am Senthil Kumar. My personal website is www.senthil.sirc.co.in. My sister concern is www.sirc, S means Success Innovative Research Center.co.in. Okay. So this is my aspects. You can see about my profiles, and you can see my complete kind of discussions and threadings and forums in my website, and you can see about my industries, my company's research activities in my company sirc.co.in, and you can see about my forums. Please, if you wanted to come to my website, you please go and see about the forums. I'll have a brief discussion about my ideas about the science and technology. What I was diagnosed, I expressed in my website in the forum page. So please go through the forums in the different discipline, and you can go through my ideas and different kind of thoughts in my mind regarding the science and technology. Definitely I feel it will be useful for you to take into the next elevated trajectory to succeed in the science and technology, which will make us to very highly advanced technology, in this case of science. So I am a computer science engineer. Even though I am a computer science engineer, I am working on multidiscipline, likely to be mechanical, electrical, electronics. So as we know that physics is a root for all engineering. One kind of outsourcing, we call it as mechanical, kinematics. High voltage kind of inheritance, we call it as electrical. Low voltage kind of electricals, we call it as electronics. So everything is, and civil engineering is one kind of inheritance, and this is also one of the child of this one. And computer science is the grandchild of the physics. Let us come to the topic now, and I am going to describe my opinion and thoughts about this physics. And first I took the topic called force. In this case, my first topic is force, and I will discuss about this force. So first of all, what is the force? Force is nothing but I have a two object 1, object 2. I have an object 1 and object 2. This distance between these two objects is r. So this is interaction between these two objects, in this case of kinematics, or in maybe an electrical, or maybe in magnetic kind of scenario. This we call it as force. It can be an interaction between these two objects, and it can be an repulsion, or it can be an attraction, or it can be an repulsion. So this we call it as sorry, I have to write the right diagram, because this kind of things we call it as, it can be a repulsion, or it can be an attraction with these two objects. This we call it as force. And when we are classifying this force, and when we are describing about the force, and I have to write the form, there are 3 different domains of this force. First domain is magnetic, second domain is mechanical, third domain is electrical. So these are all the 3 different domains, but in every domain we have a formula called F is equal to, in the first, for example, I will take about this mechanical. In this case of mechanical, my formula is F is equal to capital G into M1 M2 by R square. So this is the universal formula for force. This is the universal formula for force in mechanical domain. Okay. If I take about electrical domain, I have to write F is equal to mu into Q1 Q2 by R square. If I take about magnetic domain, I have to write F is equal to mu into M1 M2 by R square. So this is the case. But if you notice down, and you can find this, there will be a correlation between these 3 forces. The formula is same, only the thing is correct. So when I am taking about the kinematics, this is an M1 and this is M2. When I am taking about the electrical, this is Q1 this is Q2. So when I am taking the magnetic domain, it can be M1 and M2. Okay, let us come to the first one by now. First one is mechanical, and this we call it as capital G is universal gravitational constant, and these two are masses of this one, mass of object 1, mass of object 2. This is mass of object 1, mass of object 2. R is nothing but distance between these two objects. Okay, so this is the general formula for universal formula for physics. But when I am inheriting further, in this case of mechanical as concerned, sorry, I'll write it clearly right now. When I am writing it as a further extension, F is equal to M into G. That we call it as W. This we call it as weight. So weight and force both are same in this case. Weight is some kind of force. It's not a mass. Mass is different, weight is different. So mass into gravity we will get weight. So this is possible in the surface of this earth. So next one is another formula we might have experienced. When I am correlating this, let us see now. When I am correlating this formula, I will get M into G. So when I am evaluating, this is G into M1 by R square into M2. So this is, we call it as G here. This is, we call it as M here. So G is nothing but, this G is nothing but acceleration due to gravity. So it is an acceleration factor. So G is an acceleration factor. Let us describe about the another formula of this kinematics. I have the another formula is equal to F is equal to M into A. So A is nothing but an acceleration. So M is nothing but mass of an object. But so in this case of universal aspect, this is the universal gravitational constant, mass of the earth and distance within this distance between the object and the distance of this radius, we call it as radius of this earth, and this is mass of this object. So this is, we call it as M into G by this case. So let us this is then we call it as force by now. And if you take an electrical kind, this mu is called permeability, and Q is nothing but the electrical charge of the object conductor 1, electrical charge of object 1, electrical charge of object 1, electrical charge of object 2, and this is distance between these two objects. Okay, let us take now, and I will have an object 1, object 2. It can be an static electric, or it can be an harmonic wave, whatever may be the case. Based on the polarity, they will have a force based on the polarity. If it is an harmonic, it will get, if based on the phase angle mate, and based on the phase angle it may attract or it may repel. But basic principle is, if they are in out of phase with each other, they will be attracted. If they are in phase with each other, they will be reflected. So when it is in harmonic, based on the phase angle meet and based on the polarity, they may get attracted or they may be repelled by this case. So this is the case of electrical. If it is an harmonic or square wave or triangle, whatever may be, it cannot be depend on the wave structure. It depends upon the polarity of this one. If over a time period, over a time instance, it's in terms of over a time instance, at that time, what is the phase angle between these two conductors, object 1 and object 2? Based on this phase angle meet, they will be attracted or repelled. If they are out of the phase with each other over a time, they will be attracted. If they are in same phase with each other, they will be repelled. So this we call it as in electrical. It can be a conductor, or it can be an object, or it can be a collection of conductor, it can be an inductance, it can be anything like this. So if you that's why when you go close to the transformer, you will get sound like drrrr, like this. So this sound is due to this phase angle meet, and this will make some force related one, so that they will make some vibration. So due to that frequency we'll get this sound. Okay, so this is about this electrical. How about this magnetic? The magnetic, this we call it as permeability of this atmosphere. It may be, and for example, I have a magnet here. This is magnet M, this is M1, this is magnet to M2, and this is the distance between these two object magnet is R. And when I am classifying this is the F is equal to M. This R is this one, and this M1 is this one, and this M1 is this one. So this is the case, and this is the permeability of this atmosphere. So this atmosphere will be, and permeability of this atmosphere we call it as mu here. So we have to, when we are saying about, there will be one correlation in this case. This G mu is only correlated in this one, and these two are object 1, object 2. These are object 1, object 2, distance among these two objects. This R is same, and M1 is M1 here. M1 M2 are we call it as mass. Here Q1 Q2 are called as charge. Here Q1 M1 and M2 as magnetic pole strength of this magnet. This M1 and M2 is pole strength of this magnet, and mu is nothing but permeability. So we have to realize by now this time is capital G is also some kind of, one kind of kinematic kind of, mechanical kind of permeability, and this is electrical kind of permeability, and this is magnetic kind of permeability. So we will have a different topic on permeability in the next lecture. Maybe I plan to take a next lecture on permeability. So let us go to this one. So G1 mu G mu is nothing but permeabilities, and these are all objects in this case. So next one is, I would like to take a little aspects on classification of the forces. What are the different classification of these forces? This topic now. So next one is classification of these forces. We call it as classification of this. When I am having the classification of this force, I can classify as, one is based on this vector direction. And second one is domain. Based on this vector direction, I can say it as attractive. It can be repulsive. Whereas in case of domain, I can classify into mechanical, magnetic, and electrical. So this is what in this case. Then when we are further been realized, we have this one. In this case of mechanical, we will have an attractive, we have a repulsive. In electrical, we have attractive. In magnetic, we will have attractive, and we will have repulsive. In electrical, we have attractive, we will have repulsive. So we will discuss about it now one by one. So we say it as based on the vector direction, we can when the classification of the force based on this vector direction, we can say it is an attractive or repulsive based on this vector direction. What is in vector direction? For example, I will have an object here, object 1, object 2. Okay, so this may be attracted by here 1, or this may be repelled by here. So this is repulsion, this is attraction. So based on this case, so when I am saying about this mechanical and magnetic and electrical, I'll take the electrical because that is everyone knows about this electrical, and then we'll go to the mechanical, magnetic, and then finally we'll go to mechanical, because mechanical there is a questionnaire that we are not diagnosed now. So when I have a charge here, I have an object here, object 2, object 1 in electrical domain. So we have an object 1, object 2. This may be positive and this may be negative. if they are in this object, it can be in the object, can be a wire or a conductor or any kind of coils like an inductance or maybe any mutual induction, something. We have learnt ample number of options, maybe an inductance device or maybe a capacitance device, maybe an any simply a conductor. We can have like this. So when I have this two objects, on object 1 and object 2, and the distances among these two is r, and we'll experience the force. So when they are in this different polarity, they are attracted. And for example, if both of them are plus, they will be repelled. When it is plus minus, when it is plus plus, or minus minus, or minus plus. When it is plus minus or minus plus, it will be attracted. When it is plus plus and minus minus, it will be repelled. So this we call it as in this electrical domain. When I am saying about this magnetic domain, I have this object 1, object 2, M1, magnetic pole strength of this magnet 1, magnetic pole strength of magnet 2. The distance between these two is r. When they are in the magnetic north, they will be attracted, repelled. When north or south, okay, attracted when north-south or south-north. This is in this case of magnetic domain. This we know it. But when I come to the mechanical aspects, when we are saying about the kinematics aspects, and we should have to realize something interesting here, that we know this, when we take a force between these two objects, we say only about this attractive forces, but we didn't define about this repulsive forces. But there are also a repulsive forces. We'll discuss now, so how it is possible now. So when I have this attractive and repulsive, when I am saying about the general formula for mechanical, F is equal to capital G into M1 M2 by R square. So this M1 and M2 are, we call it as masses, and G is nothing but a universal gravitational constant, and R is the distance between these two objects in this space. Okay, so let us come to here. We will have a formula like this, and this is the formula for an attraction. This is the formula for attraction, and we know, but how about for repulsion? Sorry. How about the formula for repulsion? Do we realize there is only repulsion is also possible in mechanical? Yes, I feel, because when we have an example, I'll have an aspect, I have an hydrogen atom here and I have an oxygen atom here, okay, and I'll do 2H2 plus O2 will give an H2O. This is a very basic example, because this is a very root for us to understand this concept of repulsion. We have an hydrogen atom and the oxygen atom. We have an oxygen atom here and we'll have two hydrogen atom here, and when they are bonded together, we will get this, we call it as oxygen, this we call it as hydrogen. So when these two hydrogen atoms and oxygen atoms are mingled, we will get an water. Okay, so here we will say about this, the force among these two, we will call it as G into M1 M2 by R square. But whereas in case of this one, when I am defining it now, if we have this force, we have only, assume that we have only attractive forces, we don't have repulsive forces. When we have discussed about the attractive forces, we have an oxygen, we have an hydrogen atoms. Since we assume that we have only attractive forces, we don't have repulsive forces. When the hydrogen atom, the oxygen atom is initially here, the hydrogen may be something here, somewhere else and somewhere else. When they are integrated and when they are fused together, and they will be getting close together, and it will comes to here and stay over here. Why not it will come to here and stay over here, like with some distance, with a reasonable and correct distance. It will come to the right distance, and stay over there. And if you wanted to move further, not even a single microns to nanos kind of distance close to the oxygen, it may not be possible. It may not possible. For example, I'll have a hair here. When I'm giving a pressing an hair, when I am pressing an hair with around 1000 newtons or 1 lakh newtons, the air may be compressed, but it cannot be. It's like an elastic. It will be come back to its original positions. The one thing we have to realize it, when you are compressing it, this you cannot make not even a single movement beyond this distance. It is saturated with this distance. When it is in distance in nature, they are attracted together and they will come to close together and keep a certain distance with a right and comfortable distance between these two atoms, oxygen and the hydrogen atom. They will keep that distance and it may not be getting close together. Why not? If you have the only attractive forces, this hydrogen and the oxygen atom has to be fused together. And the hydrogen has to get into this, join with this hydrogen, and it will form a new atom. Okay, if it's form a new atom, even in this electron and between the electron and the nucleus, there is an attractive forces here, and this electron has to be comes together and join with this nucleus. Even though there is a we call it as an centrifugal force we have, but that is different. But that is also the case. That is one kind of enhancing this possibilities of this repulsive forces. This is centrifugal force is nothing but one kind of extending this, one kind of expression we call it as this repulsive forces. So let us come to now, if I am having the steady state, if I have integrated this oxygen atom and then the hydrogen atoms, they are come together and keep some distance, they cannot get further. If I have any material, for example, I have a steel material, ion material, Fe2O3. Okay, I have an Fe atoms and I have two oxygens, maybe some other bond like this, oxygen, maybe oxygen like this, and it may be correlated with this each other. If I am compressing it, can I make it a single component of this one? Fe2O3 as the single component. If you have only attractive forces, we don't have then repulsive forces. This oxygen and hydrogen has to be integrated, and later a stage this to be unique, and later a stage they further been integrated, and it will form a center position. They will form an integration. So one we have to realize, if after we are realizing this, if there is no repulsive forces, there is no atom, there is no world, there is no universe, there is no the solar system, there is no the galaxy. So in the kinematics, we call it as mechanical also, there is an attractive forces is there. Due to that attractive forces, the object cannot be getting mingled together over a parameters. So because of that aspects, the atoms are getting close together over a distance, and they will maintain, because of this repulsive force is also being there. There is an attractive force and also there is a repulsive force. Due to attractive force, they get close together from this position to this position. These positions, the attractive forces and repulsive forces both are been same in this nature, so it occupies this position. It cannot move further because the repulsive force is extending it not to get close together. Because of this regions, this atom looks like an atom, the molecules looks like an molecule, and the material looks like a material, and the world looks like a world, and this universal system, solar system, everything is existing because of this attractive and repulsive forces. Both are then present in every part of this molecules, even starting with a photon to galaxy, it is being present in this repulsive force. So we have an repulsive force, and we should have to realize what is an repulsive force and what is the formulation for the repulsive force and how it has been, and we have to realize it. Please, I request, it's not a centrifugal force. Centrifugal force is one kind of experiencing and one kind of expressing this repulsion force by this physics, mechanical kind of physics, mechanical kind of force. So we have to make a question and we have to do a research on repulsive forces, so that it will be good enough in this case of space science and the luminal velocity, maybe an high kind of interplanetary transportation. In the many aspects it will be useful in this case of repulsive technology. So you have to realize this repulsive force in this case. Okay, so this is what we have discussed about this force, and force is like this. I think so I have covered a little bit on my idea about this force, and I will take you next lecture on negative forces in this case. Okay, thank you. So today in the last lecture I discussed about this force, and we have classification of the force, what is force and what is the classification of this force we have discussed in the previous lecture. But now I am going to discuss about this term called negative forces. And when we are discussing about the force, we are discussed about the positive forces only, and when we are discussing about the positive forces, we will discuss about this, we call it as attractive force and repulsive force by direction, vector direction. By the domain we can classify as mechanical, electrical, magnetic. These are all the three basic domains which will in our case of science. So with us we have, in this case of mechanical, we have attractive and repulsive. In electrical we have attractive and repulsive. In magnetic we have attractive and repulsive. So these are all the different kind of forces, but here we will discuss about the negative forces which is involved in this case of forces concern. So let us assume here we have two kind of negative forces. Is basically when we are classifying the negative forces, we have two different kind of forces, which is drag force and friction force. And what is a negative force? For example, I have a object here and I have been in the surface. This is the surface of this, maybe an earth or anything. This is object 1, this is object 2. This is object 1, this is object 2. When I am pulling it here, I am just pulling it here, I lack a force here, and the object is moving. When object is moving in this direction, it experiences the friction force over here. This force will have a negative force region. Negative region. This we call it as friction force. One kind of force, this we call it as friction force. This we call it as friction force by this case, and this is usually happen in this case of surface area, surface of the material. Friction force is usually happen in this case of solid materials. Usually most of the time it is almost like maybe 98% this friction force might be happen in 99%, this will be happen in solid objects. So due to this solid objects only we will experience this friction forces. The friction forces will have in surface of the material, and it will have this happen in solid materials. So whereas in case of other force we call it as drag force. This is our first kind of force is friction force, second kind of force is drag force, and this drag forces happen in all the directions within an object, all the direction by within an object. The object 1, we have an object 1 here, this is an object 1, this is object 2 here. I have a flight here, this is an object here, this is object 1, this is an object 2 here. So here this we call it as, this may be a fluid system. This is a fluid and this is a solid. Maybe anything, it's not a constant. The drag force is usually between this, we will term between the solid and fluid forces. The solid is within the fluid, this we call it as within the fluid. So the fluid, for example, the flight is moving in the air, when the flight is moving in the air, it experiences the fluid forces. We call it as the drag forces in the every part of this flight when it is in the contact with this fluid. So this force we call it as drag force, and this will be possible in all the directions. We call it as within this object. So within the object, and this we call it as this one, this is possible within this liquid and gases. This is possible within this liquid and gases, or maybe colloids, or it can be possible within the liquids, or it can be possible within the colloids, or it can be possible within the gases. So it is possible in this case of we call it as drag force in this case. And friction force is usually happen in the surface of the material, and it is between the between solid materials. For example, I have, this is a solid material, this is also a solid, these two materials are solid. For example, I'll write it here, this is solid, this is also a solid, this is also solid, and this is also solid. So between these two solid materials, in the surface of the object, we will experience the force called friction force. Usually the friction force is possible in the surface of the material, and drag force is possible within the material. So it will have all directions, every part of this surface will have an interaction with this one. But when we have realized about this friction and drag force, but in this case of drag force, it may be happen in this case of liquid and gases and colloids. What is in liquids and gases and colloids? Liquid and gases and colloids, they can, structurally there is not a static one. Whereas in case of solids, structurally it is static. Whereas in case of liquid, gases and colloids, they are structurally instatic. Not static, we call it as instatic, because it cannot be this position of the atoms or molecules in this gases may not be the static one. It will keep on moving in this case, and they are structurally can be dynamically changeable. And even when we are discussing about the flight is moving in the air medium, so when the flight is moving in the air medium, the molecules in this air medium will make some momentum with this flight wings, or maybe the flight wings and the flight. So this is nothing but a very tiny, very extremely tiny particles of this solid. So if you take an, for example, I'll have an object is O2, for example, I'll have an object of oxygen, or maybe an if you take any other materials which is in the oxygen, so the oxygen atoms will hit this one. It's like a simple oxygen molecule will hit this surface of this flight, and it leads to experiences this, momentum with this one, and it will dynamically changes its based on momentum. It will be heated, and it will be getting reflected or refracted. We call it as a reflected or reflected, means it will be momentum based on this action of momentum. It will changes its positions by means of reflection and reflection directions of this principle by this. So it will be moved. So it's like a tiny part of, very extremely tiny part of solid, we call it as a liquid. So the liquid is dynamically changing its structure, and it's structurally it is not static. Whereas in case of solid, it's structurally static, so it is very hard to change its state. Whereas in case of liquid, it's keep on changing even in the normal positions. When the flight is moving, it tries to change, and it will be experiences this force with a tiny momentum. This integrated form of all the tiny momentum, we will call it as a drag force. Okay, even though there is a very tiny moment of this one, this will be acted in every part of this one, and it can dynamically change its structure, and this will experiences the force called drag force. Whereas in case of solid, it will have happened in the surface of the material, and it may not supposed to, it doesn't like to change this one. It will experience the force, negative forces over here. This force we call it as friction force. Let us take here, I have an object here. Let us take here, I have an object here, object 1 here, object 1, and I will have an object 2. Maybe this is table. Let us take it is a table, and here this is here we will have, I'm giving a force to here, and I'll have this experience. This is a table surface, and when the object is pulled, I'll apply the force here and trying to pulling it. It experiences the negative force over here, and here there will be different kind of forces acting here. One force is this one, F, and another force is acting here, that is M into G, that we call it as weight, that we call it as W here. So I'll have a weight here, that is by the by the earth, and there is a little force between this object and the table. So that is also the another force between these two objects, that is by the formula F is equal to G into M1 M2 by R square. But this force is very less between the table and the object. So this is also one kind of force, attractive force between these two objects. And among this, when these kind of forces acting, when I am applying the forces here, it experiences the friction force which will resist it and make it has to be the force. The friction force has always been tangential, 180 degree inclination to this applied forces. Usually it might have been happen. So usually it might have been 180 degree up inclination to the friction force. It directly opposite to this applied forces. So it experiences negative forces. This we call it as friction forces. So this we call it as friction forces. Whereas in case of fluids, I have an experience of this fluid, it moving in this one, it experiences the structure of this air is keep on changing, so the fluid will keep on moving, so it experiences this force, and this we call it as fluid force by this lecture. So with this I am concluding this lectures. Thanks for watching my lectures. If you have any queries, go through my website and you can raise the question on this. I'll think about this your question and I'll reply after I was diagnosed your question. I found an answer in my mind and reply back to you. Please go through my website www.senthil.sarc.co.in. Thank you. Bye.